All right, here we're looking at some probability here. All right. What are the chances? Let's take an example, rolling a pair of dice. Okay? What's the probability of having a sum, rolling a pair of dice, not paradise, but a pair of dice, and having a sum less than 6, or a sum greater than 10. Can it be both? Could I have, roll a pair of dice, okay, throw a dice. Is it possible to have a sum less than 6 and also greater than 10? No. Okay? So we call this type of situation mutually exclusive. Okay? This is a type of event that is mutually exclusive. Over here in this circle, we have a sum less than 6. Over in this circle, we have all the numbers where the sum is greater than 10. So really our choices are either 11 or 12. And so you throw a pair of dice, it could be either 5, 6, 6, 5, or 6, 6. Here we have all kinds of choices for being less than 6. Okay? 1, 2, 2, 1, 2, 2, 2, 3, 3, 2, and so forth. Okay? All right. How many choices do we have altogether throwing a pair of dice? How many on one die?
6.
How many on another die?
6.
6 times 6.
36.
All right. I feel like a preacher. Yeah. All right. Joel Osteen. Just kind of. All right. We don't need any comments. I just threw that out there. All right. Well, this is an example of events that are mutually exclusive. Suppose I said, all right, we're going to throw a pair of dice where we have a sum that is less than 10 or a sum greater than 5. Notice the word or. If I had the dice 1 and 3, would that satisfy that?
Yes.
Yeah. Okay. So, could it be both? Yes. If it could be both, then we say that this event is inclusive because there are numbers that are included in both. And what that might look like, here's all the ones less than 10. Here's all the ones greater than 5. And then right in this area, those are all the numbers that satisfy both. So it could be the sum of 6, the sum of 7, the sum of 8, or the sum of 9. And that would include both, wouldn't it? And we call that an inclusive event. All right. So, if they are exclusive, mutually exclusive, we have a formula for that. The probability of two events happening. The probability of A or B is equal to the probability of A plus the probability of B. Let's take a single die, and we're going to say the probability of a single die. What's the probability of rolling an even number on a single die? 3 out of 6. Okay. The probability of B, what is the probability of rolling a die and rolling a 3? 1 out of 6. Are they mutually exclusive? Can it be both? Can it be an even number and 3? No, it can't be both. It can't be even and 3. 3 is an odd number. It can't satisfy both of these. Therefore, it's mutually exclusive. Therefore, we follow this formula. And the probability of A, which is 3 over 6, plus the probability of B, which is 1 over 6, it's a probability of 4 over 6. If you think about it on the simple terms like that, it's easy. You have 4 out of 6 chances to get either 3 or an even number. It could be 2, 3, 4, or 6. Right, Will?
Yeah.
Stay with me. Let's take a problem that is inclusive. Take a single roll of a die. Inclusive. Probability of A plus the probability of B minus the probability of them both happening at the same time. Okay, so let's take this scenario. If it's inclusive, this is not. This is mutually exclusive. So what is the probability of an even number or the probability of a 4? Can it be both? Yes. How many ways can I throw a die and get an even number? How many ways can I throw a 4? 1 out of 6. There's only one way. So it's going to be a 4. Is that supposed to be funny? Oh, okay. I didn't know. You can only throw 4 one way on a die. There's only one 4 on there.
Yeah, I thought we were kidding.
2 die, yeah, just 1 die. Okay. So let's use that formula. The probability of A plus the probability of B minus, what's the probability it can be both? Even and 4. 1 out of 6. There's only one chance out of 6. When you roll it, it can be a 4 and an even number. Okay? 1 6 minus 1 6, and so we get 3 out of 6. So it could be a 2, 4, or 6. And it would satisfy both of these. Mutually exclusive. Okay? Does that make sense? All right. Now I want you to turn to page 654. Page 654. All right, if you notice in a survey about a change in public policy, there's 100 people that were surveyed. 100 people surveyed. sounds like, what's that game show? Family Feud. 100 people surveyed. All right. They were asked if they favored the change, opposed the change, or had no opinion. Okay? And then it's broken down into how many men there are, how many women there are, and the totals. Okay? And we have 50 men, 50 women. So it's going to be out of 100 people. Find the probability that a randomly selected respondent to the survey opposes or has no opinion. Okay? How many people oppose or have no opinion at all? Now, are they mutually exclusive? Yes, they are mutually exclusive. Can't be both. You can't oppose it and have no opinion. Okay? So, those that oppose are 37 out of 100. This is mutually exclusive. Those who have no opinion, how many?
36.
36. So 73 people out of 100 either oppose or have no opinion. That means that 27 people favor. Okay? Now, and I think I'm going to roll in the next topic along with this. If this is a probability of something happening, let's say this is the probability of something happening, we'll call it C. This is the probability of an event happening, which is those who oppose or those who have no opinion. That means that, do you know what, if I wrote that, do you know what that would mean? Well, not the inverse. It's called a complement. It's called a complement, all right? Meaning, who does not oppose or have no opinion? And that would be the other 27. And that is called a complement. And that's how we write a complement, all right, with an apostrophe there. All right? And they should add up to 100%. If this is 73%, those who oppose or have no opinion, and this would be the people who have an opinion, should add up to 100%. Take example 2. Find the probability that a randomly selected respondent to the survey is a man or opposes the change. Okay? So how many men are there?
50.
There are 50 men altogether. Okay? Probability of man or one who opposes. How many oppose? 37. Plus 37 out of 100 minus the probability of both, a man and who opposes. And how many is that? 12. There are 12 men that oppose. That's the probability of both. Okay? And so we have 50 plus 37 is 87. 87 minus 12 is 75 out of 100, or 75% are either a man or opposed. Okay? Get the idea? This isn't the first example I gave you. Mutually exclusive event. This is an example of an event that's inclusive. Okay? So, what we're going to do tomorrow is we're going to go over the problems in this lesson. And then tomorrow I'm going to pass back your test, your last test that you took, and we're going to do the test corrections. We're going to go over your test, and we're going to do the problems out of this section. So tonight we can just go out and enjoy the nice weather and
Go to Roxbury.
be happy.
Go to Rochester.
Go to Florida.